Let's now look at how we can use the binomial distribution to test if claims are actually true or false. So let's say that we're told that x follows a binomial distribution where there are 20 trials and a 0.4 probability of success. I'm just going to set my calculator up to do this now. And what we want to know is this the correct probability? So perhaps we've had some claim, maybe we've bought a packet of seeds and we've been told that 40% should germinate, but when we actually grow our plants, we find that it's less than 40% that germinate, and we suspect that this is an incorrect claim. So we're going to state two hypotheses. These are the claims that we're investigating. The first hypothesis is what we call the null hypothesis. That is our default position that we're trying to disprove. So in this case, we're testing the company's claim that 40% of seeds will germinate. We then have our alternative hypothesis. This is what our counterclaim is. In our case, we think that the probability should be reduced from 0.4. We suspect it is less than 40% which germinate. So, if you look at the GeoGebra file, you will see that the binomial distribution is basically made of lots of little blocks which look a bit like this, and each block represents the probability of a certain number of successes. So for example, maybe this is 0, 1, 2, 3, 4, 5, 6, and so on. Okay, our one we would expect to be centred on about 8 as the most likely, as 0.4 times 20 gives us 8. But that's the general shape of most binomial distributions. You can see that if you look at the GeoGebra file attached. Okay, so what are we actually trying to find here? Well, let's say that when we actually plant our 20 seeds, we only get 3 germinate. So if we just draw a section of that probability distribution that we'll have the probability of 0 successes, 1, 2, 3, 4, 5, and so on, getting larger and larger. So we said, let's say that only 3 of our seeds germinate. What we'll do is, we'll look at the probability that we would have got 3 or fewer germinating seeds. So we'll look at the probability that x is less than or equal to 3, and that comes out as 0.016. Okay, so what's that telling us? That's telling us that if each seed did have a 40% chance of succeeding, then if we planted 20 seeds, there's only a 1.6% chance that 3 or fewer seeds would germinate from those 20. Well, is that sufficient to support our claim? What we would need to do before we actually plug in our data and see the probability, we would have to decide on a significance level. Basically, how small a probability, because remember, there is some finite probability that 0 seeds would germinate, even if all 20 have a 40% chance of germinating. So what percent chance are we going to say is too small and that we think we must just have the wrong model? Usually in A-level maths, this is taken to be a 5% significance level. What that means is, if the probability of your event or more extreme occurring, so in this case 0, 1, 2 or 3 seeds germinating, has a probability of less than 5%, we have sufficient evidence to support our counterclaim. So we've seen that is less than the 5%, significance level we were using. Therefore, we reject H0, saying that we do not believe that that is the correct probability, and we accept H1. We accept our counter proposal. We must then have some sort of context. So always answer the statistics questions in context. The probability of seeds germinating, we would say there is sufficient evidence, because remember, we cannot say with certainty. There was still a 1.6% chance that that was the correct probability. There is sufficient evidence that the proportion of seeds that germinate is less than 0.4 or 40%. Okay, so we state our hypotheses, having stated our model. Our null hypothesis is always that we're using the correct probability. We then read the context of the question. In this case, we thought the probability was too low, so we said that our alternative hypothesis was that the probability would be less than 0.4. We then looked at the probability of our event happening, 0.016, that was less than 5%, which was our chosen significance level. Therefore, we rejected H0, that was the wrong model. We should have chosen one with a lower probability. We say there is sufficient evidence to support that claim, and we must have context. Okay, in the next video we'll look at how we can deal with probabilities which are greater than probabilities that are stated, and also we'll look at two-tailed tests.